So our exam review, the second page, all the stuff about relations and functions. Describe the similarities and differences of relations and functions. The big thing about relations and functions is both are sets of x and y pairs. So that's how they're similar. The difference lies in that a function is more specific. A function is a relation, but a function is more specific. In a function, each x value can have only one y value. Each x value can have only one y value. And so if that's the case, what you want to do, particularly when you're evaluating function tables, is you go down and make sure your x's aren't listed twice. I've got an x of 100, it's got one y value, x of 200, one y value, x of 300, one y value. It's a function. Each x only has one y. In number 13, are any of my x values repeated? Every x that appears only has one y. Same rationale, right? 12 and 13? You like that? Both of them. Same explanation. Khalil.
Okay, so as long as the y's can repeat, as long as the x's don't.
I love how you just said that. The y's can repeat as long as the x's don't. The y's can repeat as long as the x's don't. And the thing about it is, I'm going to just use this as an example, you guys. There was a vertical line test. Vertical line test. This one wouldn't be a function because when x is 1, see how it's got two different y values? But really, I don't care if a y value repeats. I mean, think about that even with our parabolas. Do I care that y gets hit twice in a parabola? No, because it still would pass the vertical line test. I'm just trying to, talk a little bit more so you can remember what this is all about. So what's the issue on 14? Negative 2 has two different y values. Therein lies the issue. So not a function. When x equals negative 2, there are two different y values. It's a relation, but not a function.
So what was the second difference?
That was analyzing tables for quadratics that we did in Algebra 1. Wasn't the second difference is half of the a value?
Yeah.
And we found different techniques to get at that stuff. Yep. And now, number 15. 15 has domain range. Okay, so ignore my little blue parabola that I put on there to talk about functions. 15 would not be a function. If you want to, make a note. Not a function. In this one, it wasn't part of the question, but it doesn't pass the vertical line test. And what that means is there's certain x values that I see two different y values. Doesn't pass vertical line test. But actually, this problem wanted the domain and range. And for number 15, the domain are the x values that make sense in this situation. I'm just going to go along the x-axis. It starts right here at 0, and I can see that this function would keep going on and on. There's arrows here to tell me that it's going to keep going on and on. So the domain in this case would be x is greater than or equal to 0. It's going to keep going on and on. Now I'm going to grab a different color for my range values. What I see for my y is that, again, this is going to keep going on and on. It's going to extend up and down. My range is really all real numbers. There's nothing that's not going to show up on the y-axis where this function doesn't have an x value with it. Now, when you're over on problems like 16, bless you, 16, I'm going to list my range using brackets and commas. The range is all my y values. Can you just put the title range at the top of your table? I want you to write them this way. I'm just listing them. My domain is just the list. Oops, Set notation 1, 2, 3, 4. Domain range, graph table. Expect both of those to see them in both a graph and a table. And then I'm going to move over to 17. Khalil, go ahead.
So the domain is the x values, the range is the y values.
Sure is.
When one is repeated, you don't repeat that when you write it down.
Oh yeah, good reminder. You guys remember this? Khalil's saying if something repeats, you don't list it twice. Exactly. Something repeats in your domain or range, you don't list it twice. In 17, 18, 19, you're just evaluating for specific values. F of 5 should give you a y value of -7. When I go over to 18 and I plug in 1, h of 1, -5 times 1 plus 2 all over 3. H of 1 is, I'm just going to simplify, -5 plus 2 all over 3. H of 1 is -3 over 3. H of 1 is -1. I'm going to move over to number 19. F of 15 is equal to radical 15 minus 6. 15 minus 6 under the radical is 9. F of 15 is simply 3. Sure. Taylor's asking, can I finish and do this? Fantastic. That's what function notation lends itself to, is to be able to pull out the point.